It is about 12 o'clock. Getting ready to start our heat trace series number 3. Today we are going to be talking about specifically heat trace design strategies and also the design tools that are available online. Okay, first I want to give you guys a little bit of a hint if you have any issues. With the webinar jam, there is a reconnect button that's on the upper portion of your screen. If the audio or the video freezes or cuts out for any reason, just hit that reconnect button. The right-hand side of your screen, you will see 3 dots in a red box. That will allow you to get into the chat mode. If you have a question or you just want to chat in and say hi, how you doing, please feel free to put anything you'd like in that chat. And if you do have a question, we will try to answer it during this webinar. If we run out of time, we will answer that question in an email afterwards. All right, so here's the quick agenda. We're going to go through a quick introduction of myself and the Dale Prentice Company. We're going to then really get into the heart of this, which is going to be some design strategies to talk about, and then the tools that are available, both industrial and commercial tools. So my name is Melissa Melton. I have been working with the Dale Prentice Company now for over 25 years and have done a lot of design work throughout the company in different positions. Most recently, in the last 9 years, I've been doing the outside sales engineering work and also doing some field technical service work. So whenever you have a project, a problem, an issue that you want some expertise on, not only do you have myself to count on, we also have many other experienced individuals in our company, and I'll talk about them in a little bit as well. So Dale Prentice Company, as you probably know, we are a Michigan-based company. We are a local provider for industrial and commercial equipment. We deal a lot with technical and generally safety type equipment that we both represent and distribute in our Oak Park facility. So some of the heat trace solutions, and I've talked about these in the past 3 series or 2 series, specifically on heat tracing. So you should be well acquainted with the applications there. Some of the other things that we deal with are some detection systems, some medium high voltage terminations, splices, things of that nature, overpressure protection, and flow control management through valve actuation controls. We also have a field services company that helps with field service, repairs, testing, automation, and also in-house where we do relief valve testing and stamping as well. So we've talked about some of these applications in the past. Today we're going to get more into design strategies around these applications. Some of these are going to be very generic, and some I'm going to try to hone in a little bit more specific to the application. I'm not really going to go into design strategies for leak detection systems or the floor heating, but know that we do have a full line of solutions for those categories. So design strategy number 1. When it comes to heat trace systems, there's a lot of components to think about. The main components that drive the element of the actual heat trace to heat or energize is going to be really at the power connection source. And then, of course, you want to have safely all the way through to the termination point, or the end seal kit, as we call it. The components in between, you can have splices, you can have T connections, but anytime you can reduce the amount of connections you have in a system, the better that system is going to operate, the less potential issues you might have in the field with water getting in connections and things of that nature. So when I look at a design, whether it's a pipe design or whether it's a gutter design or even a snow melt in the concrete, I'm really looking to strategize on where the heat trace goes. Can I double back on that T off that pipe instead of providing another T connection, as an example? In a roof and gutter, can I put the heat trace down that downspout and then come right back up and continue on that gutter without having to do T connections in that particular area? Those types of strategies are going to provide, as I said, a much more longer solution, and also cost. It eliminates the cost of labor to install them, as well as the component itself. Design strategy number 2. So the higher the voltage you can give us, the longer we can go on circuits. And I will stress this, with self-regulating heat trace, whether it's ours or whether it's a different brand, doesn't matter. Self-regulating heat trace does have an inrush current. When you start up a system, it depends on how cold that cable is. It depends on how cold the atmosphere is around the cable. That really drives the inrush current amount. So as you see, we've got a maximum circuit chart on the screen right now, and we really do advise going based off of these circuit breaker charts. Do not go based off of simple math of the amount of volts and the amount of watts that the cable produces. You will undersize your circuit breakers and your wiring and have issues. But going back to the strategy number 2, as an example, if you looked at an application and you told me you only had 120 volts, but say the gutter, between the gutter and downspout, you are 250 feet. Well, with 120 volts, that's going to push you into 2 circuits. The maximum on a 30 amp breaker, even if you started at a temperature of 32 degrees outside, which would be pretty much a thermostat, your maximum is only 200 feet. Now, if you can provide me 208, 240, or even 277, you can see on this chart how much more length you can get out of that system, which would require less components, less circuitry, power wiring, as well as circuit breakers. Those kinds of things will be a cost savings in the end for you and the owner. So again, the higher the voltage you can give me, the more we can do with that circuit. Now I will emphasize, this chart only goes up to 277. This is self-regulating cable. When we get into applications that might be more productive to go to an MI cable, we can do that with even a higher voltage than 277. We can go up to 480 volts. We can also maximize when you can give us 3-phase in many cases in our control strategies, which we'll talk about in a minute. But again, just as a quick refresher, self-regulating heat trace, which is on the left-hand side of your screen, it does modulate itself, which is a great thing, modulates energy, doesn't necessarily have to have as tight of a control to it, but there is some disadvantages, and one of those is the higher the voltage. So if you want to go up to 480 volts, it's more difficult to do that in a self-regulating cable. So those are things to think about when we're looking at which cable is more appropriate. Design strategy number 4. So methods of control. If you're looking for an individual control ratio, one circuit to one control, that might be a good design strategy if you're looking to have a tight band on that pipe temperature. You're trying to maintain a specific pipe temperature. But if you've got a lot of, say, freeze protection lines out in the field, and it might be a better advantage to use those in a group control method. So where you have one physical controller measuring the ambient temperature, and that then would energize multiple circuits. And you can do that a couple different ways. One way that we're showing in this particular design is through a distribution control panel, which we do offer for both industrial and commercial type applications. But we've also used other forms of group control. In some instances, we will customize a relay contactor panel to do that same type of group control. So we have a lot of different tools available to us that we can look at depending on the price point, depending on how many circuits, depending on your voltage. Those kinds of things can come into play. So when we're looking at methods of control, things to think about are going to be, again, are you trying to just freeze protect something? Is it okay if that pipe varies its temperature 40 degrees because we're not really sensing that pipe temperature? Or is it really more critical that we know what that pipe temperature is doing and that we're within a tighter band? That might be where we look at line sensing. We also have energy savings conservation measures in a lot of our smarter controls called PASC, and that proportional ambient sensing modulates the energy output even further than the self-regulating technology. And so you really maximize on savings for energy. So when you're looking at an application, are you looking at, do you really want to know what's going on with that pipe? Or do you want to monitor it? Do you want to know what the temperature is? Do you want to know if there's current on or off? Ground fault, that's a big one. So if you want an alarm for a ground fault, those are the kinds of things that you need to think about when we're looking at what type of controller is appropriate for the project. Or is it simply you want to know if there's continuity and voltage running through that heat trace line, and we can do that simply with a lighted end seal. So those are some of the strategies that we can use and manipulate based on the needs of the owner. When we look into specific applications, we might look at things like our automated snow control system, or if it's a hot water pipe application, we're going to be looking more specifically at, say, the HWAT Eco. Or we get in further, maybe you have multiple applications. Maybe you have a project that has pipe freeze protection, roof and gutter, surface snow melting, hot water, even floor heating or freezer frost heat prevention. All those things are, in today's world, something that we can bring together into one control unit called the Axis 30, or in the industrial world, the NGC 30. So those are some of the things that we like to have that discussion with you and decide, what's the best method for controlling that particular project. Okay, the last design strategy we're going to talk about today is going to be using your local support. You obviously know myself, I live in the Traverse City area. I do travel the entire state of Michigan, but we also have other local representatives who are great resources in Grand Rapids and Midland, and of course in our Oak Park office where our local inventory is. So combined with all of the sales engineers, we have over 75 years of combined experience, and that's something that I would really encourage you to utilize. We've got a lot of sales guys who have been working in the fields for a long time. They know how to help with things like troubleshooting, technical support, or just simply asking, answering questions over the phone on a design strategy. So please feel free to use us to your advantage. All right, so let's get into some design tools. Nventthermal.com is going to be the main website that I would encourage you to go to. When you get there, if you go up to resources and then hover and click on your design tools, you will see you have industrial, commercial, and even residential design tools. The residential side of the business, Prentice Company does not get into. We can help facilitate. We can help put you in the right direction if you do have a residential application. So let's talk about industrial design tools for a minute. SnowCalc Pro is a program that is offered for the industrial heat trace line that is a downloadable software. So if you don't want to go to the internet every time, you want something on your computer, that is probably the best tool I would suggest for you. If you don't want to download something onto your computer and you'd prefer to use the online portal, TraceCalc.net allows you to do that. So let's go ahead and get into TraceCalc.net for a minute. So of course you first have to select what country you're from. Now, I have already logged in as a user. For those who have not done this before or logged into a Nvent thermal design tool, you will be prompted and asked to register. Once you have a login and password, it does allow you to get into any of these design tools as needed. So you only need to do that one time, and then you're able to get into these design tools as you need. So I created this pipe freeze protection example. As you can see, I don't use this tool very often. I use the TraceCalc Pro on my computer. So you can create a new circuit, or you can go to an existing circuit and modify it. Let's go ahead and create a new circuit. You can kind of see some of the information that you're going to need in order to fill this out, which, by the way, I will put on the webinar jam here in a minute. We have a couple downloadable files for you, and one of them is a worksheet that really helps you fill out and manage a lot of this information that they're asking for on these design tools. So temperature, first and foremost, you want to know what is the application? Is it freeze protection? That would be, I would consider 40 degrees maintain temperature. If you're looking at a process that you're needing to maintain at a higher elevation, you obviously need to change that factor. That's a very important one. Are the conditions on an outside pipe, or are we talking about a pipe that's inside of a building that might be heated? So your minimum ambient temperatures may be something that need to be selected and changed. So as you go through, there's a lot of variations that you may or may not pertain to you. So if it doesn't pertain to you, you can skip over them. The valve type, very important. Is it metal? Is it plastic? You can select what type, pipe diameter, and of course pipe length. And we talked a lot about this on the series number 1, some of the critical information that you're going to need in order for you to design. So once you have this all figured out, you can save it, and then you can go to see results. When you go to see results, it brings you into a page where it shows you a bill of materials. This one happens to be 5 BTV cable, and it gives you all the values that might be critical for your design information. Circuit breaker, I will point this out. We talked about inrush current with self-regulating heat trace. The circuit CB current is 9.7 amps. The circuit operating current is 4.7 amps. So the CB current is really what we're taking into account with the inrush current of the heat trace cable. If people want to figure out how much it's going to cost them to operate the system, that's where you'd go to this operating current, and which you can see it's about half of the inrush. So it's a pretty important distinction. Okay, so let's go ahead and go to Nvent Thermal again. Go to our resources, design tools, and now let's get into a couple of our commercial design tools. You can see there are a couple that are the same roof and gutter de-icing calculator on the industrial as well as on the commercial side, as well as the SnowCalc. These are the same programs. The only differentiation is if it's for an industrial application, but there's no difference in the actual calculators themselves. So I'm going to go into a roof and gutter de-icing calculator. I'm going to go ahead and start my design. As you can see, this is a tool that I use pretty heavily online. This is the only calculator that I have. You can't download this one. So it is something that you do need to maintain online. The main bits of information you're going to need on this, the key is going to be your voltage. As we talked about, the higher the voltage you can give me, the longer circuits I can maximize on. So this will take that into account when we're looking at our maximum circuit sizes. Controllers. We talked about a few of the controllers. We didn't go into model numbers, obviously. So if you get into this selection and you're unsure of what controller is best for your application, again, use your local sources. If you want to give us a ring, give us an email, we can help go through that selection and give you the pros and cons. So this is area number one. Area number one, you can go just a roof, you can go a roof and a gutter and a downspout, or you can modify this and say, you know, I don't really have an application where I want to put it on the roof. I just want to put it in the gutter and in the downspout. And you can select things based off of your specific width and depth and length, how many downspouts you have, those kinds of things. We talked about minimizing your components. So this is one category where you have that control. Loop downspout cables. So if I said no here, it would automatically put T connections instead of looping the cable. So if I have a 15-foot downspout length and I say loop it, it's going to give me 30 plus feet of cable. If I say no here, it's going to minimize that length of cable and give me an extra component. So I'm going to say yes, I want to loop that cable down and back up. If you're going on the roof and you have valley areas, this is also another important one to note. Valleys are usually a really big area where you have ice and snow damage to a roof. And then, of course, if you have specific scenarios where you want to add components, you can do that as well in this particular area. So once you are done modifying roof, gutter, and downspouts, you can save the changes and view the results. When you do that, it gives you a nice project detailed report. So it says, okay, this is area 1, this is what you've selected for your particular application, and this is the bill of materials that comes out at the end of it. Now, if I had multiple applications, all I have to do is say new area, and it goes into area number 2. And by the way, you can change these names, so you can continue on if you have 4 different areas on a particular building, and then the report will generate and give you the breakdown per each area. So that is the roof and gutter application. The Again, let's go to the nventthermal.com website. Go to Resources and Design Tools. And let's go into the SnowCalc program. I'll show you that here for a minute. Start designing. This looks a little bit different, but as you can see, I do quite a few projects in this particular program as well. You can modify what it's viewed based off of. So if I wanted to put it in order by the created date, I can click on that link at the top and change what the created date listing is, positive or negative. If I want to start a new project, I simply hit the plus. Project name. This city, I will tell you that it doesn't matter what city you're in. If you're in, say, Grand Rapids, Michigan, you cannot, unfortunately, select your exact city. What this represents, and if you go through the design guide, it also has the same chart. This represents areas where we have weather bin data. So in Michigan, my go-to generally is Detroit, Michigan. For most areas, I just simply modify based off of that category. If you want something a little bit more severe in terms of areas, you might select something like, I don't know, Wisconsin or Minnesota, something like that. Voltage, again, the higher the voltage you can give me, the better I am. Imperial, because we are in the United States and we don't go based off of metrics. All right, once we're into the example project, you need to start your actual design, and that is going to be the plus sign again. You can call that particular area whatever you want. I'm just going to select a name. Now here's where it becomes important to understand the products. You have the Raychem minerally insulated cable, or MI cable. That's the constant watt version cable. And then you have the electromelt version cable, which is the self-regulating heat trace. So you will need to know, and you will need to select that particular area. Wattage output, 35 watts per square foot is designated based off of the region that we selected. So based off of Detroit, Michigan, 35 watts a square foot is generally utilized. However, if I'm doing anything in a wintry condition or in a northern climate, I will change that, and depends on where it is and what the application is. But for right now, let's use 45 watts a square foot. Number of expansion joints, if I don't know at this time, I leave it as 0. Total square foot area, obviously that's very important. I have 120 square foot area. Conduit allowance, what that means is how far is your power connection kit going to be from that point to the point that your sidewalk or your concrete heating portion starts. So if my power connection is going to be right next to it, maybe I only need to put 5-foot conduit allowance. If it's going to be extended and you're going to have a longer conduit feed, you may need to modify that number. Maximum circuit breaker sizing for electromelt, the maximum you can do is 50 amps. I'm going to go ahead and leave that as 50. Save and calculate, and that then gives you your design results. So you can see how much footage of cable it's going to be. It gives you a really good bill of materials, how many power connection kits, junction boxes, and even cable ties to give you a good selection that you can now take this information and come to us with a quote request if you'd like, or ask any assistance on looking at the design. Is it okay? Is there any modifications we would do to it? Those kinds of things. All right, so I saved and calculated it already. Now I'm going to go back. This is kind of a quirky area, in my opinion. There's not a way to bounce back. When you save and calculate, it does save your design, but Then you want to go back to your project name, and then it would give you a listing here. If I had another area that I wanted to add to this, I could simply click add here again. Since I don't, I'm going to go here to the project bill of materials. And now you can see it not only selects the cable and components, it's also selected what they've recommended for a controller and also for sensors. Okay. That wraps up our 30 minutes lunch break. I appreciate your time. We will be doing one more webinar series that will be Wednesday, August 5th. So it's in about 2 weeks. Again, same time, 12 o'clock. And this will be on installation tips and troubleshooting. We get many, many calls on how to designate or figure out, find what location might be an issue, if a breaker has tripped or something's not working properly. So this next series hopefully will give you guys some really quick fundamental things to start looking at that might help your service technicians not waste time and maybe find the problem a little bit sooner. If you've missed series 1 or 2, you can go to the Prentice Co website. Specifically, the address is www.prenticeco.com/training. And then you can go in and hit the replay for the series 1 or series 2 webinars, and you can certainly rewatch those or forward that on to someone else in your company. If you feel there's someone who could get some value out of these short 30-minute sections, please feel free to do that. Otherwise, if you have any questions, as I said, feel free to put that in the chat box. We will email you a response and answer any questions that you might have. I'm also going to put on the screen real quick the worksheets. If you are interested in the pipe request for quote worksheet, that is on there, as well as a quick reference guide that, especially in the industrial components, that just gives you some quick pointers on how much extra heat trace you need for valves or how much tape you might need to install on a 4-inch pipe, those kinds of things. And it's just a nice quick reference guide. Again, my name is Melissa Melton. If you have any questions, please feel free again to put it in the chat box, or you can email me. My email address is mmelton@prenticeco.com. Otherwise, thank you so much for attending today, and have a great rest of your day.